Proxima b has long been a subject of fascination for astronomers and astrobiologists alike. It is located within the habitable zone of its star, Proxima Centauri, meaning that its distance from the star allows for the possibility of liquid water on its surface. This characteristic alone has fueled speculation about the potential for life on the exoplanet. Although Proxima b is much closer to its star than Earth is to the Sun, Proxima Centauri is a red dwarf much cooler and dimmer than our Sun. As a result, Proxima b could theoretically sustain conditions suitable for life, despite its proximity to its parent star. The JWST, with its unparalleled sensitivity to infrared light, allows scientists to observe distant planets and detect heat signatures and other emissions that ground-based telescopes and older space telescopes cannot. In recent months, the telescope has focused on Proxima b, with hopes of finding indicators of habitability. However, what the telescope found went beyond scientists' expectations. Unusual light patterns were detected on the planet's surface, with regular intervals and a brightness level not typically seen in natural phenomena. These lights seem to mimic the glow of city lights on Earth, sparking intense debates and discussions among scientists. While it may sound like a scene from a science fiction movie, the data supporting the existence of these lights are intriguing. The lights are not constant but appear at regular intervals, suggesting some form of organized energy source. Initial interpretations proposed that the lights could be the result of volcanic activity or some other geophysical process unique to Proxima b. However, the regularity of the light's patterns led scientists to question whether they might actually be artificial. Could they be evidence of an advanced civilization harnessing energy on the planet's surface? The JWST's detection of this phenomenon relies on its highly sophisticated instruments, especially its near-infrared camera, NIRCam, and mid-infrared instrument, MIRI, which can detect heat signatures and light emissions from distant planets. By examining specific wavelengths, scientists can identify the chemical composition of the atmosphere and any unusual heat sources that could suggest artificial structures or processes. When the JWST turned its gaze to Proxima b, scientists were particularly interested in identifying atmospheric gases like oxygen and methane, which could be indicative of biological activity. Yet, the strange lights present an entirely new puzzle. If these lights do indeed have an artificial origin, they raise a host of fascinating questions. For instance, what kind of technology would be required to generate such consistent light patterns? On Earth, city lights are generated by electrical grids powered by various energy sources, such as fossil fuels, nuclear power, and renewable sources like solar and wind. If Proxima b harbors intelligent life capable of building cities, what are the implications for our understanding of energy use in alien civilizations? Furthermore, how advanced would a civilization need to be to build such a visible infrastructure? One possible explanation is that the lights are a result of a process known as optical SETI, or search for extraterrestrial intelligence in the optical spectrum. This concept, which has been studied by researchers for decades, suggests that advanced civilizations could use focused light beams, such as lasers, to communicate across vast distances. If the lights on Proxima b are indeed artificial, they could be attempts at signaling or broadcasting messages. The regular intervals of the lights might contain encoded information, similar to how radio waves have been used in Earth-based SETI efforts to search for extraterrestrial signals. Alternatively, the lights could be produced by highly reflective materials or advanced technology structures that emit light as they convert energy. This scenario could involve a civilization that has harnessed the power of its star in a manner similar to the hypothetical Dyson sphere concept, but on a smaller scale. Such a civilization might have constructed enormous, energy-absorbing structures on the surface of Proxima b that glow due to the heat released in the energy conversion process. However, the hypothesis of artificial city lights on Proxima b is not without skeptics. Some scientists propose that the observed lights could be explained by natural phenomena. For example, the planet might have a highly active volcanic system that generates heat and light in patterns that mimic artificial lighting. Certain types of minerals, when heated, can glow, producing a phenomenon called thermoluminescence. If Proxima b has unique geological characteristics, such as mineral-rich lava flows or a highly magnetized surface, it is conceivable that natural processes could produce the lights observed by the JWST. Another natural explanation could involve highly reflective ice crystals or polar auroras that produce light patterns due to interactions with Proxima Centauri's magnetic field. Like Earth, some planets with atmospheres and magnetic fields experience auroras, where charged particles from the star interact with atmospheric molecules to create colorful displays of light. On Proxima b, these auroras could potentially occur at a much larger scale, illuminating the surface with city-like lights. As the JWST continues its observations, scientists are gathering more data to determine the true nature of the lights on Proxima b. Researchers are using a combination of spectroscopy and photometry to analyze the light emissions in greater detail. By breaking down the light into its component wavelengths, scientists hope to identify the specific elements or compounds responsible for the emissions. This information could reveal whether the lights are indeed artificial or the result of natural planetary processes. The analysis could take months or even years, as the scientific community scrutinizes every piece of data in an effort to avoid drawing premature conclusions. The implications of confirming the presence of an extraterrestrial civilization on Proxima b would be enormous. Not only would it transform our understanding of life in the universe, but it would also force us to reconsider our place within it. Philosophers, theologians, and scientists alike would be compelled to grapple with the implications of knowing that we are not alone. However, the discovery would also raise questions about how humanity should proceed. Should we attempt to communicate with this civilization, assuming it exists, or would it be wiser to observe from a distance, given the potential risks of initiating contact with an unknown and potentially more advanced species? Even if the lights turn out to be a natural phenomenon, the discovery is significant. It would reveal that Proxima b is a planet with active geological processes and possibly a complex magnetic field. Such characteristics would make it a compelling target for further exploration, especially as scientists look for planets beyond our solar system that might support life. Future missions, such as those involving robotic probes or advanced telescopes, could focus on Proxima b, building upon the JWST's discoveries to deepen our understanding of this mysterious world.